Very good morning to everyone. As part of our Python learning journey, we are going towards our next step. Till now, what we have done is we have done a REST simulation, basic baseline REST simulation, and we exchange a packet in between them. Also, we use a function generator to generate the random vehicle speed sample and feed that to the vehicle speed signal transmitted from the BCM node. This is what we have done till now. But when it is come to REST simulation, the people require some sort of user interface to interact with the CAN signals. Those are transmitted by different software nodes. For example, in BCM, we have vehicle speed, which is transmitted periodically right now. So there should be a user interface. Using that, we should have a permission, or we have an access to change the vehicle speed using that user interface. How to design such thing in Python? Can we design such a GUI as we have in Keno, vector Keno? We have panels, using panels, we change the vehicle speed and every other stuff. Can we create such thing in Python? The answer is yes, we can do so using a library called Tkinter in Python. And the Tkinter is a de facto standard GUI built into the Python standard library. So you no need to install anything new. So when you install Python, you are installing Tkinter along with that one right now. So Tkinter is something like a basic GUI in the Python. So it uses the windows to contain your controls. The controls in the Kinters are called as widgets. Like we have a text box control, label control, buttons control. Like that, we have different controls in panel designer right now in vector Keno. The same thing when it comes to Python, we call them as widgets, text widgets, label widgets, button widgets, like that. Most of the GUI actions that we do in the Keno are possible in Python for the things like we have something called as a meter, and then analog gauges, and then clinometer, and then this one like compass. Those things we can build our own. It's not like it cannot be implemented in Python at all. It is possible. Maybe we have to write a library for that. We may do it in future. Right. As of now, we are going to use something which is available in the Kinter before. We are going to use them and use them to create the GUI for our REST simulation, right? So the widgets will be populated inside a windows. So within a window, we have to populate those widgets and how to use. So here is an example that I have. I think this is a problem statement. For that, we are going to design a GUI. Create a GUI to vary vehicle speed signal transmitted by the BCM node using Kinter. So that is the assignment. So we are going to use the Kinter to create a panel or a GUI interface to change the vehicle speed transmitted. As of now, the vehicle speed has been, as per our previous implementation, the vehicle speed is changed automatically using a function generator. That means a random value generator. We generate the random vehicle speed and we populate them in a list. Then from the list, we feed one by one. That is how it is working. Every 1 second, we vary the vehicle speed in the previous implementation. As per the new implementation, we are going to change the vehicle speed using a track bar that we have in a GUI. Now, if that is the case, we have to bring a track bar we have to create a GUI in that we should have a track bar. Then from the track bar, we have to read the value and have to feed that to the vehicle speed. That is what the implementation to be done. For that, I have written a program, like I tried that program. So let me explain what I have done. The first thing that we have to do is we have to suspend this periodic update of vehicle speed from the lookup table that we created before, right, in the previous implementation. For that, what you can do, you can go to the transmit message routine that we have currently. Here, I have a threading dot timer, comma, that is within bracket one change vehicle speed. We're calling this function, no, which is changing the vehicle speed from the lookup table. That is commented. No, now that is not going to be there. Without that, what will be? So you will be having something like just a default vehicle speed, which is 0, will be transmitted. Right. Next thing is I have to create a GUI. GUI to show it to the user so that he can vary the vehicle speed using the GUI. For that, I have created a function called vehicle control. Inside that vehicle control, we have a frame, that is window, which is called as TK. That means when you want to create a window in the Python, we have to use TK. So right now, to create a window. Okay, the window need a dimension right now. It cannot be, that is, if you don't give the dimension, they will create a default dimension. So in order to make the things simple, so what I did, I set the dimension. How to set the dimension? You have to say that object name dot geometry. So the root is the object name, no? That is the root window. In that root window, geometry is 700 in length, 200 in width. So that is how we are setting it. Right. Then we are creating a track bar or a track bar that we used to create in Kenono. For that, here the function or a function name to create track bar is scale. Scale is a function. And then you have to say where you are going to create. I am going to create that in the root window. And I want to have a label for it. So when I create a track bar, I have to name now what for I am using the track bar. In case of vector Keno, we use a static text to label the track bar, no, because the track bar in Keno panel designer will not come along with a label. Here we can attach a label to it. So I call that vehicle label track bar as vehicle speed track bar. That means I'm going to vary the vehicle speed using that. And then you have to say from where you are going to start and where you are going to end. The track bar values range you have to set. So I said from underscore, you have to use from underscore. It is not just from to give the initial value. From underscore is equal to 0 and 2 is equal to 250. That means my vehicle speed is going to be changed in between the values zeros and 250 that I have set. And then the track bar, no, it can be vertical as well, vertical, horizontal, you can have any any orientation. So for us, we need an horizontal orientation. That's why I said the orient equivalent to horizontal. Then the width of the track bar. So sometimes the people want to have a bigger track bar. The width is nothing but in the height of the track bar, right? That we are setting to 20. And length of the track bar is set to 500 because I want to have a very big range. That's why I set it to 500. And then the tick interval. Tick interval means every tick will be separated with 50-50. So you will have a 50, 100, 150, like that it used to go. Then we have a command. The command is the even procedure. For see, in case of panel designer, we used to design the panel and will attach the variable, system variable. For that system variable or signal, we used to write procedure, right? No on sys where or on message. We used to, when there is a change in that signal, we used to, when there is a change in the track bar, we used to change the signal. Otherwise, when there is a change in the track bar, we used to change the system variable. Indirectly, we populate the value of the variable to whatever that we want. Here, we can directly attach the procedure to to the control. So I say the command is equivalent to set vehicle speeds. That is the another function that I have written. This function will get the value of track bar. That means whatever the current value of track bar, and will assign that to the global BCM info message which is transmitted from this node. That means BCM node. It will update that. You can ask me a question. You just called a set vehicle speed, but you didn't have any parenthesis and you are not passing any value of the scale, but how it will assign. See, when you call set vehicle speed and you are attaching a function with the scale by default used to return the current value of your track bar, right? No, that will be given to that function. That will happen automatically. You no need to explicitly specify that here. So just to call the function name. So when you call the function, automatically they will pass the current track bar value to that function, right? So I take that value passed to the set value for the set value function, set vehicle speed function, and I assign it to the message which is transmitted from the BCM. That means vehicle speed signal is the part of BCM info. No, to that signal I assign the value, right? And then I use a throw color. Throw color means your track bar used having the track bar you used to move the slider. No, that slider is on the some sort of a bar, right? That bar is called as throw. The color of the throw is black. I am setting that color to black. And then the length of the slider, what slider head we have, no, what might be the size of that one. You can set it. I set that to some 20 pixels. After that, the highlight color. So when I highlight it, what should be the color of that one. And then the cursor means when I drag the track bar head, what needs to be, how it should display. So for that you can set the cursor. There are different things available to set the cursor value, right? So you can pick one. And then active background. So the background, when I drag it, what should be the color of that track bar? That is, I set to green. And then the background color of the track bar, that I set that to gray. And then the three-dimensional width, to have a real time feeling, I set that to 10 pixels. So these are the different settings that I do for the scale that I created, otherwise a track bar that I created, right? I call that entire thing as an horizontal object. Then I pack that horizontal object with the root. That means I pack it to the root control, because I already told I'm going to associate this control to the root. Then I pack it. The moment I pack it, it will appear in the GUI right now. Then I call a root.main loop. That means I am just waiting for user input. Okay, now I created this function, the vehicle control task, to change the vehicle speed. I created a necessary GUI. If I were to call this vehicle control GUI, if I call this vehicle control GUI in my main, it used to block transmit message, and then the reception of message, everything will be blocked. So I cannot go to transmit message routine if I call that directly in the main, because it used to, there is a blocking function. No, this root.main loop will keep on wait here until the user gives some inputs, right? So as it is waiting for it, my transmit message routine will not work. This will not work. So it used to wait. That's why I just call the transmit message routine as we used to call before first. Then I put this vehicle control in a thread, separate thread. It is not associated with the main program at all. It is running in a separate thread. So I start that one. When I do so, that GUI will appear in front of me. When I change the value of value of the track bar in the GUI, automatically it will reflect in the transmitted message. So that is what the implementation that I have done. So let me check whether that is working now. Right. So for that, I have to compile this program and then I have to run this script, right? So Python BCM version 3.py. This is the file that I'm going to run now. That's all. I have a GUI here. In that GUI, I have a track bar. The track bar is having scale values like 0, 50, 100, 150, 200, like that. It has a background of gray. It is having a three-dimensional trackball. When I try to move it, its active color is changing to green. The cursor is changing to a drop, that is bottom side image. So like that. When I change that track bar, automatically my vehicle speed is changing, right? That's all. Whatever that we used to do in Keno, right? That we are able to do it in Python now. We are able to create our own GUI and we are able to interact with the CAN packets using that GUI. We are linking the signals to the GUI and we are changing it, right? So that's all here. So here I have done a track bar. No, so I have done the track bar based on the different value that I set, the appearance of track bar will change, right? So here, so you can play with the values that we have here. So by changing their values, you can see the different look. For example, if I change the tick interval to 100, it will be they will be divided into, let me change this to 100 now. See here now, 100, 100, 200, and then 300 is 250 is not there because it is 100 by 100 we are going. All right. Like that, when I change the color of this one to instead of background color we have, no? I set it to background color is gray. No, if I set that to blue, it will become blue now. See here, now it is changing to blue, right? Like that, you can play with these values to understand, to change the look of the GUI that you want to see, GUI control that you want to see. Okay, team, today we learned how to how to adjust the vehicle speed using a GUI that we created using Tkinter. Okay, no. Today I end this session with this. Let me catch you with more detail in upcoming session. Thank you. Thank you for watching.